Welcome back, my grade 9 students. Today inshallah I will talk about the last chapter in chemistry part, chapter 5. It talks about the halogens. So I will start this chapter with the lesson 1 about the halogens in general. What does it mean, halogen? The word halogens means salt formers or salt producers, because when they react with metals they form salts. That's why they are called salt formers or salt producers. Where we can find them in the periodic table, with metal or with non-metal. They are found with non-metals, so they are non-metals in group 7 of the periodic table. I will explain the periodic table in the next slide. So all of them are non-metals in group 7 of the periodic table. There are 5 halogens. What you call them? Fluorine, chlorine, bromine, iodine or iodine, and statin. So this is the chart of the periodic table. As we see here, we have columns. Okay, here we have column 1, 2, 3, 4, 5 up to 8, and then these columns or these vertical columns are called groups. And as we see, we have horizontal rows. These horizontal rows are called periods, and we have from 1 to 7 periods. Yes, in the first period you have 2 elements only. Here we have the hydrogen, here we have the helium. In the second period we have lithium, beryllium, and so on. Then we have many elements in this chart. But today we want to to explain the elements of group 7 only. They are put in group 7 because in the outermost shell, it means in the last shell, each one has 7 electrons. We start with the first element. It is fluorine. Fluorine in group 7, but in which period? Yes, it's in period 2. The second halogen is chlorine, also in the same group, group 7, but in which shell? Yes, in which period? Yes, in period number 3. We have bromine in period number 4. We have iodine in period number 5. We have statin in period number 6. But all of them, they are in the same group. In group what? Yes, in group 7. They have different, periods. Why they have different periods? Because they have different shells. We will see that when I explain the electronic configuration. So up to now we have to know the halogens. What are they? Yes, fluorine, chlorine, bromine, and iodine. We ignore in our studying the statin because statin is a very radioactive element. It has some properties of halogen, but it doesn't form salt. so it doesn't form salt. That's why we ignore it from our studying. Now we will focus on the 4 elements: fluorine, chlorine, bromine, and iodine. Yes, as I said, they are put in group 7 because each atom of halogen has, yes, 7 electrons in the outer shell or in the last shell. Now, because each element wants to be stable by 8 electrons in the outer shell, so when this element react, they need 1 electron to get stable. It means to get or to have 8 electrons in the outermost shell. Because they have 7, so they need only 1 electron. So each atom needs 1 electron to fill its outer shell by 8 electrons to be stable. As what? As the noble gases. You know, the gas or the elements of group 8. They don't react. They are more stable. So elements of group 7 needs 1 electron to get what? To get the same configuration or electronic configuration of noble gases. That means they have 8 electrons. In this case, yes, elements of group 7, yes, need 1 electron to be stable. That means when they react, they gain how many electrons? Yes, 1 electron. So their valence number or the valency is 1. What does it mean 1? The valency is 1 and they have 7 electrons. The valency, it means the number of electrons that are gained or lost. But here, all halogens gain 1 electron to get or to be stable like the noble gases. So each atom gains 1 electron, forming negative ions. Why it gains and it will be what? Yes, negative ion. Because electron has a negative charge. So when the atom gains electron, it changes from the normal state or neutral state to the negative ions. And the name changes also. If it's an atom without gaining, it is fluorine. But when it gains electron, we call it fluoride. And also chlorine changes to chloride. Bromine to bromide. Iodine to iodide. So as we know, sodium chloride, potassium bromide, or anything else. Now, what is the point that we have to know here? Yes, halogens are elements in group 7 because they have 7 electrons in the last shell. This is point number 1. Point number 2, each element gains how many electrons? 1 electron. Yes, to be stable. That means their valence number or the valency is 1. Now, when they found also, they tend to form gases in diatomic molecules. So some of them gases, some of them liquid, some of them solid, but when they change to the gaseous state, all of them in diatomic molecules. So fluorine we call it F2, Cl2, Br2, and I2. Halogens are found in nature as compounds. So in our life we find them as what? As compounds, not as element. Why? Because they are very reactive elements. Very reactive elements, that means they react with another elements forming salt, as I said. So halogens react with metals by gaining, yes, one electron, forming what? Yes, salt. That's why they are called halogens. Such as what? Yes, NaCl. Na is a metal. It loses one electron and give it to the chlorine. Now in this case, Na it has a positive charge and Cl has a negative charge. So the name now, sodium, yes, chloride. Chloride, not chlorine. This is chloride because it's in a compound. If the halogen in a compound, we add IDE at the end of the name as a suffix. So sodium chloride. So they react with metals by gaining, yes, by gaining electrons. Focus on this point. By gaining electrons. Now also halogens react with the non-metals. Not only with metals, also with non-metals, forming covalent compound by sharing electrons in this case. Such as what? Yes, hydrogen chloride as a gas or hydrochloric acid. So you have to focus on with metals, not with the non-metals. With metals only by gaining one electron, yes, and forming what? Yes, forming salt. Now, the most reactive halogen is what? Is fluorine. F at the top of group 7. Why? Because it has the highest electronegativity. Electronegativity, it means ability to attract electrons from the atoms. So the most reactive now is fluorine, and the reactivity decreases when we go down a group. When you go back to the table, yes, go back to the table now, yes, this is the table. Fluorine at the top of this group, so it is the most reactive element, and the reactivity decreases from what? From fluorine to chlorine to bromine to iodine. As I said, I ignore what? I ignore statin because it's a radioactive element from our studying. So the most reactive element is, yes, fluorine, and the least reactive element is what? Is iodine. You get it now? Yes. This one, it has the highest electronegativity. It means ability to attract electrons. That's why it is the most reactive element. And the reactivity decreases when you go down until we get what? The iodine. It is the least reactive. Okay, now, so down a group, by increasing the atomic number of halogens, yes, what will happen now? Now, at the top we have fluorine. Down a group, by increasing the atomic number, yes, of halogens, so the reactivity, yes, decreases. Then what will, yes, the color gets darker. Yes, the size of the atom gets bigger. Yes, the state changes from the gas to liquid, then to solid. We will see that when we explain the elements in this table. Yes, this is the table. This is the element of the table. I choose only group 7. Here it is the halogen, and the symbol of the halogen, the atomic number of the halogen, the electronic configuration of the halogen, and the electrons in the outer shell, then what is the valence number, and the state and the color. This is the summary for all information that you need. The first element, the name is fluorine. The symbol is F. How many electrons? What we call the atomic number here. So it has 9 electrons. The second one, chlorine, it has 17 electrons. The bromine, it has 35 electrons. Iodine, it has 53 electrons. Statin, it has 85 electrons. Now when you go down a group, what will happen for the atomic number? Yes, the atomic number increases down the group. So we will see in this case, you know, the reactivity with the atomic number. What will happen with the reactivity of the atomic number? As I said, fluorine, it is the most reactive, and iodine, it is the least reactive. Now by increasing the atomic number, the reactivity, yes, the reactivity decreases. So it is inversely proportional. If the atomic number increases, the number of electrons increases, so the reactivity decreases. Now what about the state? Look, yes, fluorine and chlorine are gases. When you go down, it changes to liquid. Then the iodine and the statin are solids. Yes, so by increasing the atomic number, yes, the state changes from the gas to liquid to solid. Also about the color. Yes, the first one is, you know, the fluorine is pale yellow, and this one is green, or sometimes you call it greenish yellow or pale green. All of them are right. You can say pale green or greenish yellow. It's between yellow and green. And this we can say reddish brown. Bromine, it's reddish brown or red brown. For the iodine, we have two states, by the way. The normal one, it is solid. We find, you know, the iodine as a solid. In the solid state, the color of the iodine is dark gray in solid state, but when it changes to the gas, so it is gas state, so in this case the color is purple vapor. So if you see dark gray, yes, if you have dark gray, or if you see, you know, find purple, yes, it is for the iodine, but in the gas state. But, you know, gray or dark gray in the solid state. About the statin, it is black. So what happens for the color? Yes, from top to the bottom, yes, it gets what? Yes, darker. Now we want to compare the atomic number and the reactivity and the states and the color. As I said, the reactivity decreases by increasing the atomic number. The state changes from the gas, liquid into solid, and the color gets darker. Yes, this one we mention it in the, yes, here it is in this slide. Yes, down a group, by increasing the atomic number of the halogens, yes, the reactivity decreases. The color gets darker. Yes, the size also of the atom gets bigger, and the state changes from gas to liquid to solid. We will go back here. Yes. The electronic configuration, what does it mean, electronic configuration? It means how to distribute electrons in the shells, and how many shells do the atoms have. Yes, fluorine, it has two shells. In the first shell, we have to put 2 electrons, and the rest, to get 9, we put it in the second shell. So this is 2, 7. In the first shell, we have to put 2 electrons. In the second shell, we have to put 7 electrons. Now, the chlorine, it has 3 shells. In the first one, we have to put 2. In the second one, we have to put 8. And the last shell, we have 7. For bromine, we have to put 2. Then the second shell, 8. The third shell, 18. And in the fourth shell, yes, 7 electron also. About the iodine, yes, in the first shell 2, the second shell 8, in the third shell 18, the fourth shell also 18, and in the last shell we have to put 7 electron. In the first shell how many? Yes, sorry, 1, 2, 3, 4, 5, 6 shells here we have. The first shell 2, in the second one, yes, 8. In the third one we have 18. In the fourth one we have 32. In the fifth one we have 18. And in the sixth one we have 7 electrons. Now what do you notice here? Yes, in the last shell we have 7 electrons for each element. So in the last electron we have, yes, 7 electrons in the last shell. That's why they are put in groups 7 according to the, yes, the electronic configuration in the last shell. So the number of electrons in the last shell equal the same number of group. But what about the valence number? Yes, the number of electrons that needs to get 8. So all of them have 7 electrons in the outer shell. So each one needs 1 electron to get stable. That's why their valence number is 1. All of them, their valence number is 1. This is according to the studying of your book only. But inshallah, in the next years, we have another studying. Now about the electronic configuration, I will explain it in individual point, because it needs explanation or more explanation to understand how can we distribute electrons. But now the general point, the atomic number, yes, increases from top to the bottom and decreases from bottom to the top. Yes, by increasing the atomic number, the reactivity decreases. It means fluorine is the most reactive and iodine is the least reactive. And I said we ignore statin from our studying. Now in the last shell they have how many electrons? Yes, 7 electrons in the outer shell. What is the valence number of them? Yes, each one, its valence number is 1. Because the number of electrons that are gained, yes, each one gains 1 electron. The states, the fluorine and chlorine are gases, bromine is liquid, and iodine and the statin are solids.